Hey, hello, welcome to 9.2.4. What kind of number is it? Day 2. Yesterday, we talked about the different number categories, classifications, which I'll review in a little bit. But before we get started, I would like you to go back over here and do your 9.2.4 Day 1 Edge Elastic quiz. You can go ahead and do that, and then as soon as you're done with that, read this, see if you get it, and then go over here to page 5, and answer the warm-up question 9-103. You can go ahead and pause right now and do your quiz, and then 9-103. Okay, so I'm not irrational. What do you mean? I'm so irrational. It's written right there on my face. Do you see how Mark Wahlberg has the number pi right here in the middle of his forehead? Right there. Pi is irrational. I love it. Genius. Okay, so uh, today we'll continue on with our discussion about rational, irrational. And yesterday we learned that there are natural counting numbers. Then there are whole numbers. That's the numbers you count with and zero. Then there was the uh, integers, which are all the whole numbers and their opposites. No decimals, no fractions, just the whole numbers and their opposites. Then we had the rational numbers, which included repeating decimals and terminating decimals and fractions and mixed numbers. Because all of those can be written as a ratio, they're rational. Then there was the irrational numbers, which included pi and square root of 2 and negative square root of 7, all of the irrationals, which are non-terminating, non-repeating decimals. And both of those rational and irrational categories, they make up a bigger set called the real numbers. And then outside the real numbers, which include the real numbers, there's a wider group called the complex numbers, which you'll learn about in high school. So that was yesterday. Today, let's see. Jessica knows that 0.57 is a rational number, so she should be able to write it as a fraction. 0.57 bar. She wonders how to write it though. She started by writing 57 hundredths, but is not sure that that's correct. Is 57 hundredths equal to 0.57 bar? So they can't be equal because I would say no. 57 hundredths equals 0.57 terminating. It is not repeating like 0.5. Let's see here. How do I do that? I know how to do it. We're just going to copy paste it. Control C, Control V. Oh, okay. Select it and hit math type it. Now we're good. Okay, so they're definitely different. Does anybody remember what 0.57 bar is? I think we've talked about it. I know we talked about it a little bit last year in 7th grade. Um, and this year we're going to be doing a little bit deeper dive into that. So let's take a look right here. With the help of your calculator, I would like you to write the decimal equivalents of each of these numbers. If the answer is a repeating decimal, write out at least 6 digits of the pattern. So if I take 19 divided by 99, 19 99ths, 19 top divided by bottom always, I get 0.191919191919. Yeah, let's just go till it doesn't go off the page. Give me at least 6 digits of the repeat. Okay, go ahead and finish that up. You can pause your computer at the video and finish up this page and then answer question G. All right, so welcome back. This is problem 9104. So did you notice anything about these numbers with the 9s under them that they all were repeating? So this one repeats 0.19191919. That's 1999s. And this is 0.391391391 when it's 391 over 999. And we know 3/9, which is 1/3 when you simplify it, is 0.33333333. 1 over 999 is 0.001001001. That's interesting. So that's kind of different from these first three. And the next one, 524, 524, 524, starting at the decimal. 19 over 999 was 0.019019019. That's different from these. I wonder why these are different. Okay, so what general patterns do you see between fractions and their equivalent decimals? What connections do these have with 9102? So 9102, we were talking like 19 over 100, which terminated 0.19. But when it's 19 over 99, it repeats. And so we might say something like this for a pattern. The numerator over a number with all 9s, like 99, comma, repeats if the numerator has 2 digits and the denominator has 2 9s, comma, like 99, the numerator will be the repeating number after the decimal. I hope I'm making sense. For example, let's make up one. 2417 over 9999 is going to equal 0.241724172417 dot. Now, what's up with these? Why are there 001001001? What is that all about? So I'm going to take a look right here and do a little writing on the screen. So as long as the number of digits is equivalent to the number of 9s, it'll repeat starting right at the decimal. But this one, I have 1 digit over 3 9s. So we need to think of this as 001 over 999. We got to match the length of it, but we can't change the value of 1. So we put the zeros up front, and that is how I'm getting 001001. So now I get 0.001 repeat all three of those. Likewise on this one, 019 over 999 is going to equal 0.019 repeat the 0, the 1, and the 9. So it's kind of a cool pattern, but now we got to go look at why it works. That's the next big goal. Okay, so let's go check it out. So 9-105, I'm actually going to do this one as a live problem instead of watching their video. You can watch their video, especially if you're at home, not with this. But I'm going to show you how you can turn any repeating decimal into its fraction. And what I do will answer basically 9-105A and B. We will do a couple more examples after that too. So sit tight. Maybe you should be taking notes on this, maybe in a notebook. Okay, so I want to write the number 0.57 bar as a ratio. Now, some of you are thinking, I already know the answer. It's 57 over 99. Great, but we need to see why that is. So when I look at this number, I can see it's 0.575757 repeating, but repeating decimals make things difficult. So what we're going to do is we're going to define n as 0.575757 repeating, and then we're going to take a multiple of n that will create the same repeat. Now, if I do 10 times n, the decimal moves over 1, and I get 5.757575 repeating. The problem is, I want to subtract these, and I want to subtract these so the repeating decimal part will disappear. I need to get rid of the repeat. But if I tried to do that forever, how do I do 7 minus 5? Okay, 5 minus 7 I got to borrow, but I have to do that forever. That doesn't work. So then what I'll do is I'll say, okay, what if I did 100 times n? So that'll move it twice over, and that'll give me 57.575757. Do you see how the part that's repeating matches this part, right? Okay, so here's the basic concept. Let me erase, I'm going to select a big group of this and erase it and rewrite it so that it's nice and neat now. So we're going to start off, we're going to let n equal 0.575757 forever. And then we're going to do, I'm going to do this above it, 100n equals 57.575757 forever. When I go to subtract that, this is gone, this is gone, this is gone, this is gone. 0, 0, everything is 0, right? And I'm left with 99n equals 57, which is a math problem I'm really good at solving. So when I divide this by 99, n is going to be 57/99. Oh, yay! Now you can always simplify this. This will actually simplify by 3's. So n is going to be, what's that, 19 over 33. And you can test 57/99. Grab a calculator here. And you say 57 divided by 99 equals, 575757. Oh, look at this 8 down here. That's funny. That's 575. The 5 that's off the screen rounded it up. So somebody did a bad job programming this calculator. Oh, I wonder if the other one I did, 19 divided by 33, the simplified version. Yay, it's the same thing. Okay, so let's try a couple more of these so you can get an idea of how this works. Okay, here is another example. Let's do 0.234234234234. First of all, how many things are repeating at the decimal? 1, 2, 3 digits are repeating. So I need to be able to multiply. If I call this n equals 0.234234 forever, I need to multiply it by enough to get the decimal to repeat again. Like, if I multiply by 10, I get 2.342342. That's different. If I go by 100, I get 23.423423. Again, different from 234. If I go by 1,000, I get 234. Oh, that's the same. So I'm going to call it 1,000, which is 234.234. 2, 3, 4, 2, 3, 4, 2, 3, 4, repeating. As soon as this block of decimal is all the same, this part just disappears. It becomes 0, and you're left with 999, because when you subtract the 1n, n is equal to 234. Divide by 999, and n will be 234 999ths. By the way, that number simplifies by 9s to get 26 over 111. I don't think that'll simplify. Nope. So 26/111ths. And you can check it by taking those two, divide top divided by bottom, and it'll work. One last example. This is going to be 0.67 bar. Two things repeating. So I'm going to call n 0.676767. Let's just do this. If I want that to shift and repeat 6767, I got to shift twice. So that's 100n is 0.67 bar. Sorry, my fault. Ooh, bad, Mr. Fudges. Is if I multiply by 100, I get 67.67 bar. And when I subtract, the bar part goes away, and I have 99n is equal to 67. Now what do? I need to get 1n. Oh yeah, divide by 99. N is 67/99. Okay, now your job. I want you to go try this algebra, this math, and figure out 0.98 bar. Show the algebra for 0.98 bar. Practice it. Go ahead and pause your video, practice that, and make sure that you can do this math. All right. So, did you try it out? Did you see how to do this? 0.98 bar. I'm going to go ahead and multiply that by 100. When you take away one of those, you get 99. Sounds to me like this is 98/99 when you're all done. There's a much more difficult version of this, like what happens if we have, oh, I don't know, what if the repeat doesn't start at the decimal? What if you get something like 0.1324444 forever? So that would be, for a better way to say it mathematically, what if the repeat starts here? All right, so the math that I showed you only works if the decimal is right up against the repeat. So step 1 would be to multiply, if we call this n, would be to go 1000n is equal to 132.4 bar. Then I need to get the repeating part to go away, so I'm going to take 10,000n and call that 1324.4 bar. When I subtract, let's subtract this way, that would be 9,000n, and when you subtract 1324.4 bar and 132.4 bar, you get 0, 2, borrow, 9111192. Divide that by 9,000, and n will be 1192 over 9,000, which can simplify, but for right now, just in speed and time, I want to double check it. 1192 divided by 9,000 0.132444444. So see how it shifted over there. So it does work. So that happens. First step would be to multiply by 1,000 to get to the repeat, and then multiply by another power of 10 to redo the repeat. And then you do the algebra again. Kind of a cool process. If you are totally getting this, why don't you experiment a little bit with that, because it's kind of cool. All right, now the next thing you're going to do is go and work on the rest of these problems. Go to 9106. You do not have to show the algebra, just give me the answers now that you know the patterns. And then on this one, I want you to indicate the approximate location of where these numbers belong. So like 1.5 is here. You're going to drag the number to where you think it goes on this number line. And then 13, I want you to put these numbers in order from least to greatest. Least on top, greatest on the bottom. So go ahead and do those problems right now. 105, 106. Oh, there you go. So those three problems are right now. Okay, welcome back. Let's see, for my answers for 106 here, I have 42 over 99. I don't think I asked you to simplify it, but you could simplify those by 3. This will be 312 over 999. This one will be 16 over 99. Oh, this is so easy. And this will be 8 over 99. Whoop, 8 over 9. My fault. Ruin it. Over 9. There it is. Interesting thing. If you did, let's see here. Can I do this really fast? If 0.3 bar equals 3 over 9, and 0.6 bar is 6 over 9, then 0.9 bar must be 9 over 9, which means 0.9 forever is actually equal to 1. See the giant 1? Forever is so far that 0.9 bar actually gets to 1. It equals 1. Kind of neat, huh? All right. So going back over here, my order for my numbers, -2 1/4 is there, -9/5. You can check these out yourself. Pi over 3 is kind of cool. It's really close to 1 because pi is close to 1. Right? And then this one, 9.099 is the least, down to 1.1, which times 10 to the first, which is the same as 11. Kind of good. And then last, I need you to take some notes to your future forgetful self on how to write repeating decimals like 0.473 bar as a fraction, and how to write the fraction as a repeating decimal. How do you know how many 9s to use? Answer these questions in your notes. That way you're ready for them when it comes to quiz and test time. What is the fraction for a repeating decimal like 0.014014? And title this Writing Repeating Decimals as Fractions. When you're done, you can read this and and then just work on check your understanding homework for tonight so that you can be ready for our next quiz. Have a great day, Bobcats.